In this tutorial video, we're going to talk about isotopes of different elements. Now, previously in class, we learned about atomic theory and the scientists that were involved. Specifically, we talked about John Dalton. One of the things that Dalton got almost right in his atomic theory was his notion that atoms of a particular element are exactly like every other atom of that element. This is almost true. The number of protons defines the identity of the element. Every atom of oxygen, for example, has exactly 8 protons, no more, no less. If it had 7 protons, it would be an atom of nitrogen instead. The number of protons in an atom of an element is known as the atomic number. So when we say that the number of protons defines the element, we also say the atomic number defines the element. So as another example, if we look at carbon, on your periodic table, you would find that carbon has an atomic number of 6, which means that it has 6 protons as well. Now, James Chadwick discovered that there were more to atoms than protons and electrons. He discovered that in the nucleus of the atom were particles with no charge, which he called neutrons. The number of these particles in an atom of a particular element might vary. For example, an atom of oxygen may have 8, 9, or even 10 neutrons and still be an oxygen atom. Any sample of oxygen will contain atoms of each type, though not in equal amounts. Samples of natural oxygen, for instance, have mostly atoms with 8 neutrons. The number of neutrons doesn't affect the chemical properties at all. In fact, the number of neutrons really doesn't affect the physical properties of a substance either. It can have a major effect on the nuclear properties of a sample, though. So, when dealing with nuclear reactions, we need to keep careful track of the neutrons. Atoms of the same element with different number of neutrons are called isotopes, and they also have different masses. We heard this term in class already, but just as the reminder, again, the isotopes are atoms of the same element that have different masses, and consequently, they have different numbers of neutrons. So the neutron and 0 may differ. And we discriminate between various isotopes by labeling it with its mass number. The mass number is the total number of protons and neutrons added up for the nucleus of that isotope. So we would take protons plus neutrons, and this would equal the mass number. And remember that your atomic number is also the same as your protons. Now, something to keep in mind here is that the mass number is not found on the periodic table. The mass that you would find for carbon, which is about 12.01 AMU, this is an average of all the isotopes' masses. So keep that in mind. Let's tackle an example. We might find something first in hyphen notation. For example, carbon 12 would be the carbon-12 isotope. We can also write it out as carbon 12 like this. Now if we work out the mass number, the mass number here is 12, which is equal to the number of protons plus neutrons. Carbon has an atomic number of 6, so it's 6 protons and then 6 neutrons. We can write this as a nuclear symbol or isotope symbol where we take our element symbol like this, we put the mass number on top and the atomic number on bottom. So an example or general case would look like this. X is our element, the mass number up here, and the atomic number down there. Let's say that we had another isotope of carbon where I tell you that there are 6 protons, which is carbon. So there's our isotope symbol, the element symbol. The atomic number is still 6 because it's 6 protons. And I tell you that there are 8 neutrons. Well, if we add these two together, we get a mass number of 14. So this would be the nuclear symbol or isotope symbol for carbon-14. So carbon-14. One thing I'm leaving out here too is the number of electrons. In a neutral atom, the number of protons and electrons are the same. So there would be 6 electrons there. Another term here is nuclide. Nuclide is a general term for a specific isotope of an element. I don't use it too much in class, so I wouldn't worry too heavily about it. Let's do another few practice problems together. Let's say we have bromine (80). This is the hyphen notation. The element is bromine, so we know that our symbol would be Br. Bromine, if we look on a periodic table, has an atomic number of 35, and the mass number is provided as 80. So this would be the nuclear symbol. If we break it down further into protons, we have 35 due to the atomic number. Electrons, if this is neutral, there's also 35, same as the protons. Neutral means no charge. And then neutrons, you would do mass number minus the atomic number here, which would be 45. How about carbon-13? Take a moment and write out the isotope symbol. You can pause it if you need to. So carbon is C, the mass number is 13, and we look at the periodic table to find that carbon has an atomic number of 6. This means that there are 6 protons, 6 electrons, and 13 minus 6 is 7, so there are 7 neutrons. In the third example, if I tell you that there are 15 electrons, 15 neutrons, and 15 protons, what isotope are we dealing with? Well, 15 being the atomic number indicates that we have phosphorus. And if we add up the neutrons and the protons, we get the mass number, which would be 30. We could also write it as an isotope symbol where we have P for phosphorus, 30 for the mass number, 15 for the atomic number. Okay, we have a few more terms for you. One is an ion. This is an atom that has a charge, and it's formed by gaining or losing electrons. So this is where the electron part comes in. We just worked with isotopes, which differ by neutrons. You know, if we change the protons, we change the atom identity, or the element identity. But an ion is the result of gaining or losing electrons. A cation is an atom with a positive charge, and we form these by losing electrons. I always remember that cat ions, or cats, are positive. Hopefully the one and only dad joke in this video. And then an anion is an atom with a negative charge formed by gaining electrons. Remember, electrons are negative, so if we add something negative, we become more negative. If we lose a negative, well, it's a double negative, so it's positive up here. I remember anions as a negative ion. That spells anion. Here's an example. Let's say that we're given cobalt plus 2 with a mass number of 59 an atomic number of 27. We need to find how many protons there are, how many neutrons there are, and how many electrons there are. Protons are easy. It's the atomic number provided, 27. Neutrons, also pretty good to find out. We take the mass number minus the atomic number, and what we end up with is 32. Now for the electrons, we got to look at the charge. We have a cation because it's positive, which means we've lost electrons. Here's one way I remember to do this. I take the protons minus the electrons, and this equals the charge. So if I have 27 protons and a charge of 2, then how many electrons must we have? Hopefully you said 25, and that would be correct. Another example, say we have oxygen, 16, and it's an oxygen anion because it's a negative charge here of -2. So how many protons are there? Well, if you pointed out 8 for the atomic number, you're spot on. Neutrons would be mass minus the atomic number. 16 minus 8 is also 8. And for electrons, well, we have a -2 charge, so if we take our protons of 8 minus electrons equals -2, then 8 minus what will give us -2? Hopefully you said 10, and that would be correct. Alright, so last but not least, I know this is a long video, you're going to see some isotope tables a lot like this. And let's take a moment and just do a couple, and then we'll do some more of these as warm-ups over the next couple of days. So hydrogen, that's H, the atomic number, if we look at our periodic table, it's that whole number, which is a 1. The atomic mass listed is 1.01. The units here are always going to be AMU for atomic mass unit. Okay, now the mass number I'm just going to go ahead and tell you here is 1. Then how many protons are there? Well, if the atomic number is 1, there's 1 proton. Remember that mass number is equal to the protons plus the neutrons. So if mass is 1 and protons are 1, there are 0 neutrons. And electrons here would be 1 because they're equal to the protons. Alright, now H+, that's a cation. That means we have lost an electron. So all of this info stays the same. Mass number of 1, protons 1, neutrons 0. But because we've lost an electron, now we have 0. Let's look at lithium. The atomic number as shown here is 3. The atomic mass, I believe, is about 6.94 AMU. The mass number provided is 7. Keep in mind, the mass number does not always equal the atomic mass. The mass is an average, while the mass number is a whole number. Alright, protons would be 3 with the atomic number. Neutrons would be 7 minus 3, mass number minus protons, is 4. And for electrons, we have a positive charge, which means we've lost one of our electrons. If we started with 3, because it's the same as the protons, and we've lost one, we now have 2. That's it.